Hey, welcome to Antminer Repair. Tonight, we're going to talk about a couple of things. One is this board. Um, Very difficult to find what was wrong with this, and I think I did. We're going to take a little side swerve into LDOs, which are the little black voltage regulators that are on the back of the board that produce the 1.8 and 0.8 volts to run these things. So I'm going to take a little short circuit over to there because this problem indirectly flows through those LDOs, although not directly. And also on like L3 boards, I hear that sometimes that's a very common problem to have to replace. So we're going to do that, and I want to talk to you real quickly about the Discord channel. I know a couple of you folks are having a hard time getting in. There is a way, if you have problems, to contact me. Maybe there's another way you can get in. But so I want to go through a couple of things. So if you like this content, please subscribe. The reason I ask you to subscribe is I do this on my own, and if YouTube's playing commercials, they're getting paid for it. I think I'd rather take a cut of that since they're going to play commercials and they'll help pay for the equipment to produce all these videos and stuff. I'd appreciate that. So hit that subscribe button. It does help me. The worst spam you're going to get is, hey, I produced another video. Or you'll be able to browse through my whole set of videos I've done. There's also a bell for notification that if you click that, it'll notify you, I think without subscribing, but I'd rather have you subscribe if you could help. But that'll notify you on things. And then in the video description, maybe underneath what I described the video doing, there is a link for Discord. The Discord channel has really taken off. It has become the place to come get information about repairing your Antminers and, in fact, some other tools. There's a lot of experts in there that have found a home that they can talk about things, discuss things, say, hey, what about this? Or how do you do this? Not necessarily a place for, hey, I get this error message, how do I fix it? It's for people that want to get into repairing it and want to learn how. And there's a lot of great people that are really helpful in there. So I highly recommend. Literally, I found out what was wrong with this board with, let's just say $125 worth of equipment total, maybe a little more. If you make a small investment, it's the cost of sending this board out on the ones you can repair yourself. I'll go through the history of this board. So anyway, let's get started. I first want to take you to Discord for a second, just remind you how to get there. So turn off the video and share this. And hopefully, it doesn't look like that worked. Yeah, I guess it is. Usually there's a nice green box around there. Hopefully this worked. But if you can't see anything great, you might even see my desktop. I don't know. But here it is. When you first sign up for Discord, when you go to that link and come to Discord, you need to make an account, I think, which is fine. This is a gamers chat, but it's actually getting, I'm on an on-base forum. It's actually getting to be a very good support forum for people trying to do stuff. So I chose this. But you'll only see two things. You'll see welcome, and it'll just say what the channel's about. However, what you need to do is click on the rules button, read the rules, be helpful. This is the purpose of Discord, our channel. All ideas are welcome. Don't be shy. Don't use foul language. Be nice to people needing help, and keep the information in the channel about the channel. So it is morphing to a lot. But what's important is there is a green checkbox right here. That a bunch of people have checked and some haven't, and I'm kind of concerned about that. You have to click this green checkbox, and what that does is assign you the rights to see all this great content right here, all of this content. So there's a lot of great stuff. We're starting to break out into miner specific areas. I'm just starting this. We're going to move things from very general to actually miner specific, and people are actually writing repair manuals for different things that have very sketchy information. So pretty soon there's going to even be authored content by some of the experts in here. So we have a lot of things in here, but just for example, just to look at some of the history back here, people taking pictures of what they're testing, discuss how to test. Just there is a ton of information in here, and I can't stress enough, you need to join it if you're going to fix your stuff. Okay, enough of that, but just remember, when you first join, you got to go click this guy right here, that green checkbox, okay? Or the white check mark with the green box. All right, so enough of that. I'm going to stop that. I'm going to go back to video. And let's go through this board a little bit. So I got this board on the new set of miners, which I still need to do a video, but that's not concluded yet on the miners I bought, because I did a video that I was looking at them and I chose some. So I do want to get back to folks on that. I was running this for a while and it came up with only 12 ASICs found. So I said, oh, this got to be easy. This board's been running, you know, it should be no problem. So I went to the 12 ASICs and I started playing around with these three. So I actually did these 12 and then these. So I unsoldered the heat sinks and I looked for solder balls. And indeed, when I got this miner, I'd use the air compressor to blow it. And one of these stupid little solder balls, you can barely see it. Instead of little brass tabs, sometimes they have a bump of solder here. It looks like one of those had fallen off. And when I used the air compressor, had blown into this chip right here, number 11. So, you know, it was a big gaping solder ball. It would have made a great video. I don't show everything I do on here. I just try to keep the farm running, if you know what I mean. But so I removed it, put it all back together. It started mining, and then came a hot day. And then what was funny is it came up with, and it still may have a problem up there, and I still may have more problems than I found, but I'll start with this one. It came up with 12 ASICs, and again, and I said, well, it can't be unless I missed a solder ball. So, you know, out comes the card, off comes the same chips, and I look at it really closely and nothing wrong. So I throw it on the tester. I just have the tester in here on a regular bench power supply, and I don't let it try to fully hash, but I start this up, and actually this makes sense. Yeah, this might make sense actually, that I got another 12. Not sure. But so I start up, and then it after I think once at 12 it goes to 0. So just the thing says 0 ASICs, can't run. So I said, oh geez, there must be, you know, there must be. I checked the voltages here with the heat sinks on and stuff, and it look, you know, it's like this should run. I kind of spot check stuff, you know, all the chips are getting voltage at the test points. This should run. So I said, oh man, there must be a really bad solder ball that's shorting something somewhere in the middle of the board that is completely just freaking out, and just say I can't run this at all. So 0 ASICs found, because I've had the problem where there's a short in the chip stopping that. If there's a major problem, it'll just say 0 ASICs. Not always the problem, but sometimes. So I decided I would remove all the heat sinks and look for solder balls. And indeed, in a lot of places, there were solder balls. And I've cleaned this chip. And I don't know why I put alcohol over here and there's this white residue. Do you see that? I don't know. For this last row, someone's been working here with something, maybe some sort of special cleaner. I don't know. Try to clean it up a little more. The alcohol got it out. So anyway, I went through here, threw it back on the tester after I went through. I pulled off like 3-4 solder balls in different places. And this board was running fine. It was fully hashing. They just weren't touching, I guess. So I put it on the tester, 0 ASICs. So then I start fiddling, you know, with the power. I only have these little clips to throw on the power supply. And I've noticed if you try to fully hash with clips like this, not going to work. I made these bar slots that fit in here to hash off the regular power supply. But anyway, started messing with that. Couldn't get it to get off 0. So as you guys have seen, and I've talked to in the Discord, I started measuring voltages on every chip. 4 points. I chose 4 points. on each side of the chip. And I just kind of methodically started this. I chose the middles first. And I just kind of went through. Oh, no, I didn't even do that first. Oh, the first thing I did was I checked the diode resistance. So I set my voltmeter on this fluke, and then you can change it to diode resistance. And I went through every single chip on every single test port back and forth on each side of the chip. So I did all the diode stuff. I did run into some weird problems. I had a problem on this chip. In fact, I could show you. You can see the meter now. So I put the meter. Yeah, I had a problem on this chip. So I put the meter here. So a normal thing on a T17, which is this board, is about 1.2, and that's 1.2. So most of these have to measure 1.2. I think there's a middle one that usually goes a little lower sometimes. Yeah, that guy's a little lower. And then the middle port, which is the RO signal, is either 7 up here or about 4. Don't use that one, but about 4. Yeah, about 4 something usually. Anyway, I got to this chip and I'm hitting 13s. Let me get this. So not really bad out of whack. I think I've seen them run with this. This one's normal. So I got 13 here, but that's the one that's supposed to be a little lower, I think. Yeah, so 13's here and 13's there, and the chip over here is 12. So, or 1.2, however you want to see it. So I marked it. You see that black mark? I used a black magic marker, and I went through again, and I think I found some issues here. You can't see that. I think I flagged this one. This one's even worse. No, this one looked okay. So he looked okay here. I'm not sure why I flagged. It could be the regular resistance. Let's check that out. I found one that had a leak on resistance, but not him. So maybe I'm not sure why I flagged him. This one, I thought had a leak on resistance. These boards tend to change. Okay, so now some other chips. I try to mark them as I go through because you can lose track. And this was kind of erroneous because this one is kind of consistent with everything else. So I thought I found something for this. Anyway, so I do all the diode resistance, and I chose that one. And then I said, well, it's not that off. I'm really looking for a large smoking gun. This, whatever's on this board is really stopping and messing up the works. And so then I went to the voltage checks, and I went the middle row, then I did the bottom row, then I did the top row. And this was the first one as I went across. I said, well, this voltage is kind of weird. So I marked it, but then I figured out, well, they're kind of all behaving that way. So either I have a systemic problem, or I have, complete board problem, or these are pretty typical for this board. And it turns out, I think, cross my fingers, these are pretty typical from this board. But I kept coming back here as I was coming across the top row. The clock signal is supposed to be 0.8 or 0.9 volts, and it was 0.8, 0.9 coming through here. But when you got to this chip, it dropped to 0.6. So I said, well, okay, so the clock doesn't work. Why am I not seeing, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Why am I not seeing 21 asics found or 20 asics found? Because that's where this chip is with the clock signal going through. I'm not. It's not airing it out. It's blowing away the whole thing. But anyway, it further made me suspect this chip, but it really, okay, so I got to do something about a 0.6 volt clock signal because it's supposed to be 0.8 or 0.9, and I think that is enough to affect it. But I kept coming back here and said, well, there's got to be more. That's not going to stop the board. There's a little green guy there. Summertime here, and they're attracted to the lights. So I focused in more, and now I'm going to transition. Sometimes I started looking at power circuits. If you take this and flip it over, and I'm going to try to be in the same place. Yeah. This right here is one of the power circuits, and these are those LDOs I was talking about. So I started exploring on that chip, you know, gee, is it getting power? And I did see power. There's another LDO. There's 2 up here and 1 down here. I'm not concerned about that one because that side of the board was good. But I started focusing in and said, why is the power on the clock a little bit low? But what's going on? This powers other things. I want to see if there's power on the chip because maybe there's more problems. So with that said, I'm gonna switch over to the microscope, and I want to show you what those LDOs look like. We're gonna leave the voltmeter back alone. And hang on, let me switch this over. All right, so I'm gonna switch to the microscope. I'm gonna switch video sources. So that's that guy. And let's get him lined up to where I have to look at him so I can point some things out. So help if I focused. Wrong ones though. He's way over there. So my finger is on where I want to talk about. Okay. I wonder if it'd help if I turn this board around. Let me try to do that. Because I got to explain some things. Let me move him in so the board stays on the edge of the table. Okay. So this is the circuit at the top of the board where that marked chip is. That marked chip's base is right here, and it's mounted right there. But this is the circuit that powers parts of the chips. So, okay, so what we have here, actually a couple things going on here on the back of this board. I think the other Antminers use something very similar. There's actually, this board's a little different than the ones I've seen before, but for each bank of chips, I forget what they call them, segment or each alignment, you have this circuit. And this circuit contains a couple different things. This 0-point resistor comes off this port that's inside the board. This spreads, I think I want to say 3.3 volts all the way across. Each one of these circuits starts, I think it starts here. It's kind of weird. This is where it's going out. But so this dot ends up over here on another one of these right here, I think is how it works. So the board gets its power for each bank through this zero resistance, just a bridge. Then it goes through this circuit, and then it enters all this mess here. All these resistors are is to right size the current and clean up the line. These capacitors just clean up the noise on the voltage line. But these guys are 2 different kind of beasts. These are what you call LDOs, or essentially they're voltage regulators. And they have 3 pins on one side and 2 pins on the other. This is the output. This is the input. The side with 3 at the top is on the left. If you put the 3 pins on the left, the top pin's your power, the middle pin is enable or ground, and the bottom pin's enable, and then you've got the power out, and then this feedback loop, they call it. These LDOs come in 2 flavors. They come in variable voltage regulators. So one of these is variable. I think this one is variable. It could be the one up at the other end of the board is variable. I can't remember. They're either of a fixed or variable. So they'll make it so there's 3.3 coming in and 1.8 coming out. Or 3.3 coming in and 0.8 coming out. But the variable ones use this feedback pin right here. They dumb it down with some resistance and feedback a different voltage to adjust this voltage down. And some of them, when you buy them, you can look at the specs and they'll say, hey, you can adjust depending on what circuitry you put here. Like, see, here there's a resistor and here's there's not. This is probably for the feedback loop to go back to set it to 0.8. This guy's probably a variable, but I'm not positive. So depending on what you feed back, so it usually has output. It probably does something with the output and sticks it right back in the chip. And depending on some logic in the chip, and actually I've seen schematics of that, it adjusts the output voltage from 3.3 down to whatever you want. So it's a neat way of dumbing down some current or cleaning up some current for that. So these two guys, this is 0.8 volt, and it goes to the board 1.8. Okay, so where do these guys end up? Why are they on this side of the board? Both their outputs come here and go through the board here. Now I'm going to take you where it goes to the board here first in a second. I want to just jump out to a quick diagram. Where on earth? There it is. My UI is changing just a little bit. I want to take you out to basically a data sheet for these, which is kind of cool. Okay, this is not this chip, but these are so common. So they make them in several like 4 pins that don't have pins. So these are like a Q, well, they call them a DRB. They used to call these like not QFNs, but something like that. But this right here is what we're dealing with. This is a very common thing. Let me see, did I have a different one on here? Maybe not. I think that's what I had. I had two I was going to choose to show you, and I guess I chose this one. So these are very similar. They're called SOT-23.5s. I don't know about the 23 surface. I don't know what this is, but you can look them up sometimes on eBay as a SOT-23-5. And somehow I did find, but I've forgotten where you buy these dudes. I know they can be made by TI, and if you had the specs, there's a way to find them. I found them. It just took a while, and unfortunately I didn't write it down. Something I have to share later. But just how this works. So you have your voltage coming in. You have to have a ground so it works, because the voltage it uses to work has to be, grounded so voltage flows to run it. Maybe for other reasons too. But you have this in pin, and then you have this enable. If you have voltage running in enable, it's on. If you turn off the voltage, like if you just had a push button switch here that turned it off, it would turn off the output. So this is just a switch, on or off. And they've got it rigged so that it can turn on voltage or off. So you notice when you're testing with your test fixture, something just all of a sudden starts up on your board during the process, so you can check your voltage on your chips and it shuts off. That's because it's using kind of logic and tools like this. So this is the enable pin. So when it's enabled, it's going to take the input voltage and throw it to the output voltage. And then I'll use this lower one. Then if you want, you can supply a feedback loop. That's FB is called feedback. This is this is probably a non-variable, non-feedback type. This is probably set at 1.8 volts or something like that, and 3.3 or a range of 1 to 5 volts in, and I think it always has to be a little bit less, but not sure. So if you read this I return this on all data sheets. It goes data sheets of chips, and while you're fixing your miners, there's not one on an Asic chip, but all these other utensils, if you can find the data sheet, you're halfway home. So this describes each one of the pins, okay? Enable pin, driving this pin to logic high, meaning it has voltage, enables the device. Driving this pin to logic low means 0 volts. Do not disables this device, okay? If you don't use it, connect EN to IN. So you'll see some circuits and descriptions in the Antminer manuals where pin 3, which is enable, is hooked up to voltage in. And that just means it's always on, because as voltage comes in, it's also going in here, and it just always stays on. That's how that works. So they're just saying, here's a voltage regulator. We're just going to dumb it down to 0.8. I want it on all the time. We're not going to do any switching mechanism on here. So the feedback loop, talks to input to a control loop error amplifier. You don't really need to necessarily know what that is. It's used to set the output voltage of the device with the use of external resistors. So whatever resistors you put in after that is what you get. So anyway, there's descriptions of all the pins. And then I think somewhere, or maybe that's above, they show a typical circuit, which is kind of cool. Some of them have typical circuits. Let me see if I can, without making you seasick of my scrolling. They talk about all the manufacturing processes. TI is rather exhaustive. I don't know if we're going to get it all. So sometimes they'll actually show a typical way to wire this in a logic board. Yes, I lost all of them. I don't know if I can hit refresh. Try this again. It's not going to let me go down there. Okay, we're taxing this. Hopefully my recording's working. So anyway, that's the data sheet for those LDOs. So I always look for the 3 pins on the left, and I know that's the input, that's the output. So you can do a couple different tests here on each one of these. The first place I go test. So now here's the ground plane where the chip, the back of the chip mount where the heat sink goes. So I put negative here, or in the case if you have your things backwards, I put positive here and then I choose negative. So I choose this port first. And then you run the tester so it spurs the voltage, and you ought to see about 0.8 volts going on these SQ7 series and about 1.8 volts on the 4Vs. I think I got that right. If I'm mistakenly backwards, not. So you can literally test at the power source or at the switching power source of the beginning of the 1.8 and 0.8 on these guys. They're on these guys, sorry. So I do it here and here. I don't know if I was on the wrong one. So these are the outputs of these guys. So I measure first. If there's no output, you can go try it over here and see if there's input. Okay, against ground here. If you get voltage and input and there's no output, you might check the enable pin. If there's no voltage on the enable, you might follow this circuit back and see what's going on with it. If there's voltage on enable and voltage here and nothing coming out here, could mean a couple things. Not necessarily that this guy's bad. It could be that the enable circuit has told it, don't put out any voltage worth beans. So so that could be. So I've made the mistake where this thing didn't have the right resistance and it really wasn't quite putting out the right power I wanted to replace it, and it didn't change a thing. The reason it didn't change a thing is the ground circuit where this guy had to go to be consumed was not good, and there was actually a short in the chip. These guys go directly up to the chip after they go through cleaning and a little bit of resistance check. The resistance is actually probably for the feedback, but they get cleaned twice with these resistors. You see this goes here, that goes there, and then they kind of float out. This goes here, and this is a ground plane, I think. Yeah, this is a ground plane because it goes over and hits the ground. So if you just, while you're working, test on these pins here, this is the output, then read the data sheet, try to understand how these guys work, because that's kind of how I've had to learn, is I pick up data sheets and say, oh, that's how that works. Okay, so we're going to follow these traces down to here, okay? So I tested this as putting out power. You can check the resistance here. Really what you want to do is check the resistance on this lead and this lead coming out, because these are the leads that go to the other type of board. And typically, where's my, typically on my T17, your boards, you have to kind of get used to and just look at a good one with just normal resistance. If I test, make sure I'm on the right line. So if I test the voltage here, or the resistance, I'll get something high like 50, 70, 80. something like that. And then if I test it here, and this guy, I usually get about 1.5. I think you've seen me do this in other videos where on the other side of the board I get 1.5 and I get a higher resistance upstairs. So just remember that, because these two outputs go to the board and they should be the same up top, okay? So 1.5 here and then something kind of big over here. It varies. It can go to 70 to 200. So, all right, so I'm gonna flip this over and go to the marked chip and refocus. Maybe oh, I am as high as I can get with this guy. Okay. So you draw your attention to those guys. So these guys are the two ports where those other two leads come from those LDO, those voltage regulators. And they get cleaned again after they go through the board. When I say cleaned, the capacitor takes out the noise on the power current. But basically they go this way and then they go into these parts of the chips. So really, in theory, the resistance on the ground plane that I measured, which was like 30 or 40, that varies, or 1.5 should be there. So after I tested all the voltages on all the chips, I said, well, that'll be something else. So I started going through all these little pairs of resistors, and I think there's some more on the other side. I choose these first for some reason. So I measure this guy. You can't see my meter. I measure that guy, and he's high. Instead of 1.5, it's 2.8. And I measure the guy next to it over here, 1.5. The other chip, 1.5. I said, well, that's weird. 2.8 is not necessarily bad, but it's not normal. Because I was kind of thinking, geez, are these shorted out? If these were shorted out, the LDO would run because it has a place to go, I guess. But it wouldn't help my chip any, because one time I messed up soldering and I had too much solder here and I shorted it out and it stopped the chip from working, stopped the board from working. That's why I kind of started looking at these two resistors on going into this chip. So, and just for your sake, this is the side of the chip with 3 resistors. And remember, you got the single one headed out. So, and then the test ports. Okay, the 5 test ports. So these lines that are here are just power lines that go through the chip, get cleaned up again, and go back into the next chip. They come back out, and then I think they stop. If I'm not mistaken, I think they stop. But I'm not positive. And then it looks like some more come in here and lead on. I'm not positive on that. I think that guy's video in Russia tried to explain that, and I need to watch it more, see what he says about that, or I'll find out too. So anyway, back on this guy. So on most chips, I'll measure here. I'll get 1.5 or 1.6 or 1.7. I'm getting 2.8 here. When I measure this guy, I'm supposed to get 30 or 40, like I did on the back side of the board. I'm literally getting 0.5. 0.5 when it should be like 80 ohms or 80 kilo ohms, or what is it? Yeah, probably 80 kilo ohms, 80 something on this fluke meter. I don't pay attention to I don't pay attention to units as much. It just does it. So wow, this is not right at all. And this would affect the power here and the power down here. And this might affect the third chip, which is chip 12. So it all kind of started coming together to me that I've got a problem here. So then I kind of went saying, well, I kind of made a little mistake. I put the probe here and I measured here and I got 0.5. And I said, well, what is it to ground? I put it here and I got 0.4. Wait a minute, 0.4 here. That's not what I get on the other ones. On the other ones, on that side, on the ground, from top of chip, from the top of chip to ground is like 131 ohms. So it's kind of, they're high on both sides. They're kind of the same in a way, because this represents kind of ground, really. So I said, well, is this resistor shorted? So I put the probe here, and I put the probe here, I get about 39 ohms. And that's actually what all the rest of them are reading. So you know, without knowing what it's supposed to, I just keep, excuse me, I just keep kind of comparing to the other sides of the boards, assuming that they're okay. So 39 ohms is really respectful for measuring across this capacitor. So what I've come to the conclusion is, I think it's this chip. Let me go down here. And this chip, something in this circuit has a short. And I'm inclined, because of the weird diode resistance on this chip, that it's this chip that is bad. So I've come to the conclusion that this chip is defective and has a short almost to ground, I think, or short to something. Because this is ground and it's got power to ground and there's very little resistance. Or it's wrong. So this nice black dot now means I've got to pull this chip off and replace it, probably. The first thing I'll try to do with this chip is to, I'll actually flux it up. I'll put it on my plate heater on my rework station, and I'll try to reset it again. I don't know if there's a short or broken joints in here causing problems. So far I haven't fixed one doing that, but one of the repairmen will say, hey, try to reset the solder. So something might have broken here. So that's going to be how I do this, and hopefully I'll get rid of my 0 asics. And then I'm sure I'm going to find other problems on the board now. But that was interesting. At first I thought it was this resistor over here, but I think it's the chip now. So that's a little bit on LDOs and a little bit on this board and how I found the problem with this chip, which is usually a little bit more than I have to do. Usually it's ASIC 18, can't find, and I check 3 chips around. I find the bad one with resistance or bad voltages and try to reset it, and then I end up having to replace it or fix something. You know, it's kind of weird. The one thing that kept me off to do that, and I'm going to quit the video after that, is on one of these, this is chip 30. I just started thinking. I said, so here's chip 30, and here's those 2 resistors. Why on earth is it missing a capacitor? Now, it can run without the capacitor. On this board, the capacitor just cleans the line. It won't mine as well. You'll get more hardware errors probably because you got weird voltage, you know, noisy voltage going in. But I started thinking that capacitor's off. Maybe I have a shorter capacitor, so it prompted me to go look. I'm sure the capacitor's on the other side of the chip. You got to do the same thing. So I might find other issues on some chips there. So these are actually power lines going in on this side of the chip. So you can spend a lot of time testing these dudes. Anyway, that's the video for tonight. Hope you have good luck in your, geez, that almost looks like a solder ball there. What is that? It's really close. It's just, yeah, it is. Another solder ball. They're floating all over this board, I'll tell you that. I wonder if they caused any permanent damage to the chips. So I don't know where he went. Is it that? No, that's a solder ball too. Like I said, there were solder balls all over this board, but some of them weren't on there. I'll get rid of them. Trying to clean them off. But anyway, that's the video for tonight. Thanks for watching. Hope this helps somebody out there. And again, remember, hey, subscribe if you can, okay? Thanks a lot.